Chapter 4, Section 3. The objective, learn to evaluate expressions with exponents. And essential question, how do I apply the properties of exponents? The factors of a power, such as 7 to the 4th, can be grouped in different ways. Notice the relationship of the exponents in each product. 7 times 7 times 7 times 7 is 7 to the 4th. We could take the same amount of 7s and group them as 7 to the 3rd times 7 to the 1st. Or we could group them as 7 to the 2nd times 7 to the 2nd. If you notice the pattern, to get 7 to the 4th, we have to combine 7 to the 3rd and 7 to the 1st. The pattern that I see is that the exponents get added. That seems to work with 7 to the 2nd times 7 to the 2nd because 2 plus 2 is 4. So our first rule is multiplying powers with the same base. To multiply powers with the same base, we keep the base and add the exponents. So you can only do this when your base is the same. For example, 3 to the 5th times 3 to the 8th. When we're multiplying the base, we add the exponents. So that would turn into 3 to the 13th. So let's write these as one power. Remember, when it's just a number, you can put the first power with it. So 2 to the 5th times 2 is like 2 to the 1st. So 5 plus 1 would be 2 to the 6th, because we have 6 2's there. 24 to the 4th times 24 to the 4th would be 24 to the 8th. If we have different bases, like x to the 5th times y squared, there's nothing we can do. We have to keep them the same. 41 to the 2nd times 41 to the 7th would be 41 to the 9th. Notice what occurs when you divide powers at the same base. We can take 6 to the 9th divided by 6 to the 4th. So when we multiplied, we added the exponents. Now when we divide, we subtract the exponents. Because look at this pattern. If I have 5 to the 5th divided by 5 to the 3rd, the expanded version would be 5 times 5 times 5 times 5 times 5 over 5 times 5 times 5. We can cancel out 3 of those, which leaves us with 5 to the 2nd power in the numerator. So by subtracting the exponents, we're really canceling out. 7 to the 3rd over 7 to the 5th. We subtract them in the order that they're given, numerator over denominator. So we would have more 7's in the denominator, which would give us a negative. So 7 to the negative 2nd. X to the 10th over x to the 9th would be x to the 1st power, or just x. 9 to the 9th over 9 to the 2nd would be 9 to the 7th power. E to the 10th over e to the 5th would be e to the 5th. So if the numerator has a smaller exponent, you should have a negative exponent when you're done combining them. Third rule, raising a power to a power. This is where we have a base to an exponent, and that whole power is raised to another exponent. For example, 9 to the 4th raised to the 5th. In this scenario, we multiply the two exponents. So that turns into 9 to the 20th. So 5 to the 4th to the 2nd. We don't evaluate. If we're trying to write it as one power, we keep the base as 5, or whatever number we start with, and we multiply the exponents. So this turns into 5 to the 8th. 6 to the 7th to the 9th would be 6 to the 63rd power. If it's a fraction, it's still going to remain a fraction, 2/3, but we'd multiply 12 times negative 3, so it'd be 2/3 to the negative 36th power. And 17 to the 2nd to the negative 20th would be 17 to the negative 40th power. Those are your rules. Go back and clarify if you need to. Make sure your Cornell notes are filled out completely. On the left-hand side, write questions that could be answered from the material in your notes. Review your notes, highlight, underline, etc., and complete the summary before class.